So the first of our properties is multiplying powers when the bases are the same. That's what this means here, like bases. So if my base is going to be a and my other base is going to be a, all right, the idea is that I'm going to take the exponents and I'm going to add them together. So the property says that a to the m times a to the n is a to the m plus n. And the reason being that if you give something like x to the third times x squared, right, a lot of people will tell you, well, 3 times 2 is 6, so it must be x to the sixth. Well, that's not true because remember, x to the third is essentially x times x times x, and x to the second is x times x. How many x's are you multiplying all together? The correct answer there is 5, which is why I'm going to add my exponents together, 3 plus 2, which is 5. So some of my examples might be like this. If I have x to the third times x to the seventh times x, I'm just going to add all my exponents together. Remember, if you have just a regular old variable by itself, that's really anything to the first power. So 3 plus 7 plus 1 is 11. Final answer is x to the 11th power. Next question, I may have some coefficients out in the front, like if I have 3c to the fourth times 2c to the third. First, want to think about the exponents. I have c to the fourth and c to the third, and using my property, we can call that c to the seventh. Now, these are not exponents. These are not powers. Okay, these are numbers. These are coefficients out in the front, which are multiplied together. Exponents are added, 3 plus 4, and coefficients are multiplied, so I can call my final answer as 6c to the seventh. My next question is going to be d times 2d cubed times negative d to the fifth. Sort of first think about the exponents, my variables. This is really d to the first, this is d to the third, this is d to the fifth, and I have a grand total of 9 because that's 1 plus 3 plus 5. I have a 2 as a coefficient, and there's also a negative here in front of this d to the fifth, and so you can call this negative 1, and 2 times negative 1 is negative 2. Final answer, negative 2d to the ninth. For my last question, I could have y to the eighth times y to the negative second times y to the negative second. The property also holds true when my exponents are negative, and so I can just simply add these together. 8 plus negative 2 is 6, and 6 plus negative 2 is 4, and so my final answer here is going to be y to the fourth. My next property says I'm going to take a power and raise it to another power, right? So essentially, if I had x to the third as a quick example, and I'm going to raise that to the second, right? So this is a power raised to another power. What this means is x to the third times x to the third. That means when you square something, that means to multiply it by itself. And now really just using property number 1, since I add these together, this is going to be x to the sixth because 3 plus 3 is 6. A lot of people will tell you that 3 to the second power is 9, and they would be right, but this is not a number 3, this is an exponent 3, so I multiply exponents together. So my property says that my final answer is going to be a to the m times n because I'm going to multiply those powers. In this case, I may have something like x to the 10, and that's going to be raised to the 10th power. I don't know 10 to the 10th power. It's really going to be a 1 followed by 10 zeros or 10 billion. But what I'm going to do here is I'm going to multiply powers. 10 times 10 is 100, and that's my final answer. I may have multiple variables here, something like m to the second, n to the fourth, that raised to the third. I just need to do these separately. First, I have m to the second, raise that to the third power. So that's going to be power to a power, and I multiply. 2 times 3 is 6. Now move on to the n. I'm going to raise that to the third power. Power to a power, multiply. And 4 times 3 is 12. Final answer, m to the sixth, n to the 12th. Next question, I may have something like y to the second, raise that to the third, and y to the fourth, raise that to the 10th. So I have separate expressions here that I can figure out what the answers are going to be, and then we can simplify that. Let's do the first one here. Power to a power, multiply powers, 2 times 3 is 6. Second expression here, power to a power, multiply powers, 4 times 10 is 40. Now I can think about what we learned in property number 1, where my bases are the same and it's multiplying with like bases. I can take my power 6 and 40 and add them together. Final answer, y to the 46th power. And my final question here is going to be negative 5c times 3c times c to the second to the fourth. All right, so kind of think about here these first two expressions. I don't have any powers to powers, but I can multiply them together. My negative 5 times 3, since those are coefficients, I can just multiply those together and call that negative 15. C as a variable and c as a variable is c to the second. And now let's figure out this part here. This is going to be a power raised to another power. C to the second, that's a 2. C to the second raised to the fourth is power to a power. I multiply powers. Let's call that c to the eighth. And now we can use property number 1 that we learned a few minutes ago and add the exponents. My negative 15 comes over by itself, and 2 plus 8 is 10. So this is going to be negative 15 c to the 10th power. My next property is dividing. Kind of think about this if I had something like x to the 6th divided by x to the 2nd. Somebody may tell you that 6 divided by 2 is 3, and they would be right. But think about this. X to the 6th is really 6x's multiplied out, and x to the 2nd is really 2 multiplied out. So the x divided by x would cancel. The x divided by x would cancel. And I have 4 x's left over, so my final answer is x to the 4th. And what do we do with the 6 and the 2? This is 6 minus 2, which is 4. So when I subtract my powers, that would be because I divided. I'm dividing powers with like bases, so I'm going to subtract my powers. Quick example, I could have p to the 20th divided by p to the 4th. You may have an instinct to try to divide 20 divided by 4, but that's not true. We're going to subtract, and that's going to be p to the 16th. Second example, I could have now coefficients out in the front. I could have negative 12c to the 5th over 2c. All right, let's do the powers first. Remember, a variable that's by itself really has a power of 1. So that's going to be 5 minus 1, which is 4. And my coefficients are not powers, but I can actually divide those. And negative 12 divided by 2 is going to be negative 6. Final answer. Example 3. I can combine some of my properties together. Let's call this 4x to the 2nd divided by 8x. All right, so I'm going to simplify first and then divide. 4 to the 2nd is 16. X to the 2nd comes over by itself. I'm going to bring the 8x over here by itself and see what happens. My coefficients are 16 divided by 8. Let's call that 2. And x to the 2nd divided by x. Remember, that's just x to the 1. And so 2 minus 1 is just x. So my final answer is just 2x. Last question of this section is going to be 6m to the 3rd, n to the 2nd. Square all of that over 3mn. Let's square all of that. Let's do the top and the bottom separately. I'm going to square everything in the top, and 6 to the 2nd power is 6 times 6, which is 36. Power to a power, m to the 3rd raised to the 2nd, is m to the 6th. And power to a power, n squared squared, is n to the 4th. Let's square everything on the bottom. 3 to the 2nd power is 9. M to the 2nd power is m to the 2nd. And n to the 2nd power is n to the 2nd. Now we can simplify everything separately. I have 36 over 9, which is 36 divided by 9, which is 4. M to the 6th divided by m to the 2nd. Remember, our property for the section is to subtract. 6 minus 2 is 4, so that's going to be m to the 4th. And I'm going to subtract the powers on my n's. 4 minus 2 is also 2. Final answer, 4m to the 4th, n to the 2nd. And for my last property here, by the way, this piece right here at the bottom is going to go down to the next page. We'll save that for next week. This is a power of a product, so two things that are multiplied together. I really need to just divide those up and raise those both to that power, in this case, a to the m times b to the m. So I can have something like negative 4x, and I'm going to raise that to the 2nd power. We can just do these separately. Negative 4 raised to the 2nd power is negative 4 times negative 4, which is positive 16. And my x comes down. X to the 2nd power is x squared. Final answer, 16x squared. Example number 2. In the quantity, I could have 10 times b to the 3rd that raised to the 4th. So we can just do each of these separately. 10 raised to the 4th power is 10 times 10 times 10 times 10, and 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Just remember, a power of 10 raised to that number is going to have that number of 0, so 10 to the 4th power is 10,000. b to the 3rd to the 4th, power to a power, I multiply those powers, final answer, 10,000 b to the 12th power. 2 questions to go. I may have something like 2y, that quantity raised to the 3rd power, and then I may have 3y, that quantity raised to the 2nd power. If I raise everything to the 3rd power here, this is 2 to the 3rd power, or 2 times 2 times 2, which is 8. Y to the 3rd power comes down like this. 3 to the 2nd power is 3 times 3, which is 9. Y to the 2nd power is y to the 2nd. Let's now simplify this. I have 2 coefficients, 8 times 9, which is 72. Y to the 3rd and y to the 2nd. Remember, we can use all these properties together. And when I have a multiplying with like bases, I add the exponents. So 3 plus 2 is 5. My final answer here is going to be 72 y to the 5th. And my last question of the day, last question of the week, is negative 7 m squared n all over 5 p to the 3rd q to the 4th, and we're going to square all that stuff. So really, when I have a quantity with a power out in the front, I can just take everything that's inside when it's multiplied and square everything. In this case, negative 7 to the 2nd power is negative 7 times negative 7. Let's call that 49. M to the 2nd, power to a power multiply. N is by itself. We can just raise that to the 2nd. 5 to the 2nd power is 5 times 5, or 25. P to the 3rd to the 2nd is power to a power. I multiply. 3 times 2 is 6. Power to a power, I'm going to multiply. And 4 times 2 is 8. Final answer, 49 m to the 4th, n to the 2nd, all over 25 p to the 6th, q to the 8th. I hope this has been helpful, and you can use these skills for the questions that follow.